Good morning, students. Jai Swaminarayan. Welcome to our video lecture. Today, students, we are going to discuss properties of binomial probability distribution. Today, students, we are going to discuss the properties of binomial probability distribution. Before that, let us have a brief revision of these two concepts: binomial random variable and the second is binomial probability distribution and binomial random variable. In the previous lecture, students, in the yesterday's lecture, in previous lecture we have discussed all this definition. So once again I am going to revise these definitions and then students discuss in detail the basic or fundamental properties of binomial probability distribution. A random variable x denoting number of success in n Bernoulli trials is called binomial random variable. Once again, a random variable x which denotes number of success in n Bernoulli trials is called a binomial random variable, and its range is, you can say, 0, 1, 2, 3 up to n. It means it can assume any value from 0 to n, so it's where n is the number of Bernoulli trials. Number of success can be 0 also. Recall yesterday's example. Suppose if I toss a coin for 100 times and all 100 times I will get a tail, then getting a success is not possible. So x is 0. And extreme possibility, all 100 times I may get a head. So x is equal to 100 also. So this is a very important BSQ. What is the range of binomial random variable x? Then it is set of integers 0, 1, 2, 3, 4 up to students n. This is the range of binomial random variable x. The probability distribution of binomial random variable is called binomial probability distribution, and the formula is NCX p raised to x q raised to n minus x, where x can assume any value starting from 0 to n. X can assume any value starting from 0 to n. This, students, we have already discussed yesterday. So, the two definitions most important from examination point of view are this. In this formula, let us, you can say, elaborate each term. N is equal to number of Bernoulli trials. Capital X is equal to small x is equal to number of success in n Bernoulli trials. P is nothing but probability of success event, and Q is nothing but probability of failure when NCX is a combination term that could be easily understood. So another way is to, from the definition only, state the formula for binomial probability distribution and explain the meaning of each term involved in the formula. State the formula of binomial probability distribution and students explain the meaning of each term involved in the formula. This is based on the general term of binomial theorem, which I have written yesterday again. I am writing that term is PR plus 1 is equal to NCR a raised to n minus r e raised to r. This we refer in 11th standard, chapter number 6, students. It is exercise 6.3. So without yesterday's basics clear in terms of theory, students, we cannot proceed further for today's lecture. Without, students, the basics of yesterday's theories, we cannot proceed for today's concept. So Dick-Thomas experiment and random experiment, which has only two possible outcomes, out of which one is success and the other is failure, is called a Dick-Thomas experiment. Yesterday we discussed this. Now, students, today's concept is the properties of binomial probability distribution, and based on this property, students, we will try to do few short sums. So today's concept is nothing but basic theories. Again, this is totally, students, based on theories, basic theories. Then we try to do few short sums from section A, B and C of main exercise 2. Now, the first property, binomial distribution, is a discrete probability distribution. It is a discrete probability distribution. Why? Because number of success in n binomial trials are always countable or finite. So the first and the foremost MCQ which has been, students, asked in board examination, binomial probability distribution is the probability distribution of dash variable. The answer is discrete because number of success. Say suppose I am tossing a coin for 100 times. I know number of successes can be any integer from 0 to 100. So total there are only 101 possibilities which are definitely countable. So the first property of binomial distribution is, students, it is a distribution of discrete random variable. Then, students, the parameters of binomial distribution are n and p. Parameters of binomial distribution are n and p. If n and p are known, then only, students, this distribution formula is useful. Or in another way, from distribution to distribution, n and p varies. Therefore, they are called parameters. Say for one distribution, n is 10 and p is 0.2. For another distribution, n is 15 and say p is 0.7. Why parameters? These are instrumental in applying this formula. First explanation. Or this value changes from binomial distribution to distribution. So a binomial distribution is uniquely characterized by n and p, and the values of n and p, students, varies from distribution to distribution. So this is second property. Then students, mean of binomial distribution is n into p, where n is number of Bernoulli trials and p is probability of success. So this denotes average number of success in n Bernoulli trials. Students, what is mean of binomial distribution? Then students, we can say that mean is NP, which denotes average number of success in n Bernoulli trials. Fourth and very important property, variance. Variance of binomial distribution is NPQ. And as per the definition, standard deviation will be root of NPQ. All of you know that positive square root of variance is standard deviation. So, as far as mean, variance, and standard deviation are concerned, we should know the values of n, p, and q. Okay, q is not required for mean, but for variance and standard deviation, students, q is required. Then, for a binomial distribution, mean is always greater than variance. The most important property, mean greater than variance. So, NP greater than NPQ. And definitely variance upon mean will give us the probability of failure. For a binomial distribution, students, mean is always greater than variance. For a binomial distribution, mean is always greater than variance, and variance upon mean gives us q, where q is probability of failure. Then students, sixth property, based on the value of p, if p is less than half, skewness is positive. This we have to remember. If p less than 1 by 2, skewness of the distribution is positive. If p greater than 1 by 2, skewness of the distribution is negative. And for p equal to 1 by 2, skewness is 0. That is, the distribution is symmetrical. So, the last three properties, students, are very important from numerical base. As such, all 8 properties are very, very important for numerical base, students. So, one has to be very careful in understanding and applying this property. Once again, last 3 properties. For p less than 1 by 2, so 1 by 2 is 0.5, if p is 0.38, then skewness of binomial distribution is positive. P greater than 1 by 2, skewness is negative. Suppose p is 0.58, then it is greater than 0.5, so skewness is negative. And if p is exactly 0.5, then skewness is 0. 0 skewness means distribution is symmetrical. The frequency curve is perfectly bell-shaped. In that case, let's recall our 11th standard, chapter number 5. For a symmetrical frequency distribution, the frequency curve is, students, perfectly bell-shaped. So, in today's lecture, we have discussed the properties of binomial probability distribution. Students, revise this once again, and then I will teach you how this property, students, are applied to short sums. The first property is binomial distribution is a distribution of discrete random variables. So it is called discrete probability distribution. Why discrete? The number of success in n Bernoulli trials are countable. It can be any integral value from 0 to n. I told you, if I toss a coin for 100 times, number of success x can assume any value from 0 to 100 where x is an integer. Then second important property asked as MCQ, the parameters of binomial distribution are, students, n and p. N is number of Bernoulli trials and p is probability of success. Based on these two values, we characterize a binomial probability distribution. Or second explanation, parameters n and p differ from distribution to distribution. Parameters n and p differs from distribution to distribution. Then mean of binomial probability distribution is, students, n into p. The product n p, where n is number of Bernoulli trials and p is probability of success, denotes average number of success in n Bernoulli trials. So mean of binomial distribution is np. Then fourth property, variance. Variance of the binomial distribution is npq. All of you know standard deviation is positive square root of variance. So standard deviation of binomial probability distribution is square root of npq. Then fifth and the foremost most important property, mean of a binomial distribution is always greater than variance. Mean of a binomial probability distribution is always greater than variance, and the ratio of variance to mean gives us, students, the probability of failure, which is q. Now, based on the probability of success, we decide the type of skewness. Skewness of a binomial distribution is decided on the basis of the value of p. If p less than 1 by 2, skewness is positive. If p greater than 1 by 2, then skewness is negative. And last but not the least, if p is equal to 1 by 2, skewness is 0. Zero skewness means the distribution is symmetrical. So this much, students, we have to perfectly remember and memorize before doing the sums of binomial probability distribution. So, students, now let us start section B of main exercise 2. So this formulas we have to perfectly remember and memorize before doing the sums. Okay, students. So now we are starting some BSQ type questions of section B. Today we are going to do only very short sums, but students, I want you to memorize, remember the formulas, write the properties 3 times, so that you can apply to the sums. Now I am writing here parameters of binomial distribution are NP. Mean is equal to N into variance of a binomial distribution is root NP and standard deviation. Variance is NP. Students, by mistake and standard deviation is root NP. Students, variance is NP and standard deviation is root of NP. Thus are the four basic formulas which students usually apply in the short sums. Once again, let us revise these four fundamental basic formulas. What are the parameters of binomial distribution N and P? What is mean number of success N into P? What is variance of binomial probability distribution NPQ? And what is standard deviation of binomial probability distribution? Then students, the answer is positive square root of NPQ. Okay, section B, first question, define discrete random variable. We have already discussed. Once again I am discussing section B, answer 1. Today we will complete section B and then go for short sums of section C. Now in section B, the first two questions we have already discussed. Once again, students, I am discussing. Define discrete random variable. A random variable which assumes finite or countable infinite number of values in the set R is called a discrete random variable. Right, examples also. For example, number of children per family, number of broken eggs in a box of 12, number of printing error per page of a textbook, etc., etc. Then second question goes as define continuous random variable. A random variable which can assume any value in the set R or any value in an interval subset of R is called a continuous random variable. For example, the data of height and weight, the data of income and expenditure, etc., etc. So the first two questions. Now define discrete probability distribution. Remove the question 4. State the formula to find mean of a discrete variable. Remove the formula to find variance. Remove. So answers 3, 4, 5 are removed. Now answer 6. Students, answer 3, 4, 5 are removed. That is not there in our syllabus. Question 6. Mean of a binomial distribution is 7. Mean of a symmetrical binomial distribution is 7. Students, mean is NP and that is 7. And another information is given, is symmetrical distribution, that is E is equal to 1/2. This you have to understand as the hidden information. This is to be understood as the hidden information. The top 4 formulas which I wrote based on properties that only students are applying. And always you will get a short sum based on properties. So B is n P is equal to 7. Distribution is symmetrical, so P is equal to 1 by 2. Therefore, n into 1 by 2 is equal to 7. So number of repeating Bernoulli trials are 14. So this is what we have to do the sum. Okay. The parameters of binomial distribution are 10 and 2 by 5. Parameters is n and p. Our formula number 1. Answer 7. According to the 1, parameter is n and p. P is, you can say, never greater than 1. So n is 10, p is 2 by 5. Now we are told to find variance. The formula students to find variance is NPQ. The formula to find variance is NPQ. But always remember the hidden information, universally true, is P plus Q is equal to 1. So, generally, in 99.99% of the sum, students, out of P and Q, only one of the values are specified. No issues, no worries. We can easily find Q based on calculation. So we can write Q will be 1 minus P, 1 minus 2 by 5. Take LCM, so 3 by 5. So, hidden information, inbuilt information which we have to always accept is P plus Q is equal to 1. Intentionally, students, I did not write this in the list of formula because this is to be understood when applied. Now, variance has formula NPQ. So if we are going to find variance, then variance is equal to NPQ 10 into 2 by 5 into 3 by 5. 5 1s are 5 2s are 4 3s are 12. So the variance is 12 by 5. So this is how students we apply the formulas which we have written, students, in terms of basic properties. Okay, let us go further. Students, let us do the next included sums in our syllabus. The next question. State the relation between the probability of success and failure in Bernoulli trials. Already written, P plus Q is equal to 1. Answer 8. P plus Q is equal to 1, where P and Q both are less than 1. We have already written this when we have defined, you can say, Bernoulli trials. We have already, students, written this when we have defined Bernoulli trials. Question 9. State the relation between mean and variance of binomial distribution. Mean is always greater than variance. That is NP greater than NP. So according to me, students, answer 8 and answer 9 both are very important VSQs for 1 mark. So we have to remember this. It is based on memory. Okay. The probability of failure in a binomial distribution is 0.6. Probability of failure means Q. So we write according to B1, Q is 0.6. So P will be 1 minus Q. 1 minus 0.6, so 0.4. No need to give both. And the number of Bernoulli trials in E is N is equal to 5. Okay, we already are given the 10 is equal to 5. But this has no role to find Q. Q is simply, no role to find P. P is simply 1 minus Q, or Q is simply 1 minus P. So if probability of failure is 0.6, probability of success will be 1 minus 0.6, and that is about 0.4. Now, students, pay attention. Section C, we are doing question 5. Define Bernoulli trials. Okay, students, this is already done. We have already, you can say, clearly defined what is the definition of Bernoulli trials. Come on, that is only some I am discussing. The remaining sums we will do next lecture. So, section C, question 5. In section C, first 3 questions are in section C, students. Answer 1, 2, and 3 are answered. And answer 5 are discussed. What is Bernoulli trials? Suppose a dictamous random experiment is repeated n times under identical condition, and it has 2 possible outcomes, of which one is success and other is failure. If the probability of success P remains constant or same for every trial, then such trials are called Bernoulli trials. The best example, tossing of a coin 100 times under identical conditions. So as such, sums of section C we will discuss next time. Today we conclude the lecture. So hereby, students, I conclude the lecture. Write the properties 5 times and memorize. Thank you, students.